Analytical circuit analysis subject, Unit 5, analysis syllabus, expected exam problem, star based problem, that is unbalanced load, that is very important point, unbalanced load, apply 4-wire star connected load problem, and formulae, important formulae we see in this class, that is analysis syllabus, Unit 5, exam expected problem. An important formulae in this class we see. Using formulae, IR is VR and divided by Z1 is V angle of 0 degree divided by Z1 angle of phi 1 and ampere. That is modulus of V divided by Z1 less than minus phi 1 angle. That is ampere. IY is VYN divided by Z2. V angle of minus 120 divided by Z2 angle of phi 2 in ampere. That is modulus of V divided by Z2 angle of minus 120 minus phi 2. IB is VB divided by Z3. This is equal to V angle of minus 240 degree divided by Z3 angle of phi 3 in ampere. IB is V divided by Z3 modulus less than minus 240 minus phi 3 angle in ampere. IR, IY, IB are also the line currents. The currents in the neutral wire is the vector sum of the three lines currents. Unbalanced star connected problem. Problem 10. An unbalanced 4-wire star connected load has balanced voltage of 400 volt. The loads are Z1 is 4 plus J8 ohm. Z2 is 3 plus J4 ohm. Z3 is 15 plus J20 ohm. Question. Calculate the line currents, 2, current in the neutral wire, and the total power. Solution. Z1 4 plus J8 ohm. Z1 change N to polar form 8.94, the angle of 63.40. Z2 3 plus J4 change into polar form. Z3 15 plus J20 change into polar form. Let us assume RYB phase sequence. The phase voltage VRN is 400 by root 3 230.94 volt. Taking VRN as a reference phasor, we have VRN as 230.94 angle of 0 in volt. VYN is 230.94 minus 120 degree volt angle. VBN is 230.94 angle of minus 240 degree volts. VRN is obtained from 400 divided by root 3. In the same way, VBN and VYN magnitude obtained. And angle is VYN is minus 120, VBN is minus 240 degree. The three line currents or IR is VRN divided by Z1, that is formulae, is equal to 230.94 angle of 0 divided by Z1 is 8.94 angle of 63.4. Answer is 25.83 angle of minus 63.4 degree in ampere, that is IR value. IY value is VYN divided by Z2. Put record values with the angle, that is we obtained 46.18 angle of minus 133.1. VYN is angle of minus 130 degree is important. IB is VBN divided by Z3. VBN angle is minus 240 degree important. Put Z3 value, we obtained IB. IB is 9.23 angle of minus 293.13 degree in ampere. To find the neutral current, we must add the three line currents. The neutral current must then be equal and opposite. Thus, the IN is minus bracket of IR plus IY plus IB. Put IR, IY, IB value with the angle. We obtain neutral current IN value in negative value. Because the neutral current must then be equal and opposite to this sum. Put IN is I minus bracket of IR plus IY plus IB. Shown that only we obtain IN is 36.6 and angle of 33.30 degree and vector diagram we draw is shown in page. Its phase with respect to VR and S 33.3 degree. The dispersion of all the currents is shown in figure. VB and VO and VR. VR is reference point IR, IY and IB. Line in vector diagram. Power in orifice. We know power formula is I squared R. In this orifice, IR squared into RR. I put IR value into R value. We obtain power in orifice. Power in Y phase, IY squared into RY. Put IY value into RY value. You obtain power in Y. Power in B phase, IB squared into RB. Put IB value into RB value. Obtain power in B phase. Total power absorbed by the load. Power in O phase plus power in Y phase plus power in B phase. The total three phases is given total power absorbed by the load. 2668.75 plus 6997.77 plus 1277.89. We obtain 10344.41 in watts. That is answer. That is unbalanced short connected load analysis. It is syllable expected exam problem. 15 more questions answers. Unbalanced load important formula is phase voltage is VL divided by root 3. Then that is angle of 0 degree. IR is VR divided by Z2 and IY is VR divided by Z2, IB is VB divided by Z3. Angle is important. VR and put 0 degree angle, VB is put minus 130 degree angle, VB and put minus 240 degree angle. IN is minus IR plus IY plus IB. In this calculations, angle is very important. IR is VR and angle of 0 degree divided by Z1. IY is VU and angle of minus 130 degree divided by Z2. IB is angle of EB1 minus 240 degree divided by RB. Unbalanced load store connected power in R phase is IR squared or RR. Power in Y phase is IY squared into RY. Power in B phase is IB squared into RB. Total power absorbed by the load is IR squared RR plus IY squared RY plus IB squared RB. That is important formula in unbalanced store connected load 4 wire. And engineering, thank you.